Hello students, today we are going to discuss about experiment number 8 of our subject CAD CAM Automation. The title of this experiment is Assignment on Robot Gripper Design. The aim of this experiment is to study robot gripper design. Okay. So we know robot gripper is one of the important part or element in robotic system. So this is again the topic which we are going to discuss in our syllabus, and this topic includes in unit 6 of our subject. So this experiment is based on that content, and this is again a study based experiment. For submission point of view, you have to complete the write-up for this experiment. You have to solve the numericals based on robot gripper design. So we are going to discuss about fundamentals of robot configuration, the basic knowledge of robotic system, then what is degree of freedom, about different types of robot manipulator and different types of robot configuration. The objective of this experiment is to know about various types of gripper and the procedure of design of robot gripper. So here two numericals based on design of gripper I have explained. You have to complete this write-up as a submission for this experiment. Okay. So we will not go into details about this calculation because the formulas are included, and this will cover. We will cover this part in theory. Today we will discuss about the guidelines for selection of gripper and design of gripper. So these are the points or the aspect which are important for gripper design. Weight of the workpiece. Weight of the workpiece again plays an important role for gripper design. Weight means it affects on the gripper force, gripping force. Okay. Then metal of the workpiece. Of course, density again plays important role for weight and during lifting the work component. Then size and shape of the workpiece or component. The number of fingers required for gripper to hold the workpiece. Speed of robotic arm movement. Coefficient of friction between gripper and workpiece surface, ability to reach the surface of workpiece. Ability, it depends on the size or complexity of component which is going to lift and place at any location by the robotic arm or robot gripper. Then accurate positioning. This is again important because we have to assign the XY location or coordinates, accurate coordinates for the movement of robot gripper. So with respect to precise movement of robot arm, this positioning, accurate positioning of gripper is also important element in design. Then finger replace ability. Then again, there are few points which required for gripper design, or these are some restriction we can say, that gripper must not create any distortion or scratch on the workpiece surface. It should not affect the surface finish during lifting and placing at other locations. It should hold the large area of workpiece. Okay. of the dimension so that it should not affect the size and shape of the workpiece. It should hold it comfortably, and this will increase the stability and rigidity and control in the positioning of the workpiece. Resilient pads should be provided to provide cushion to the workpiece. And during machining operation, there will be change in workpiece component size. So according to change in size and shape of the workpiece, the change in positioning uh, of gripper, robotic gripper should be defined. Okay, so these are the characteristics of robotic gripper design. So this is about some guidelines or characteristic of gripper design. Now we will see the fundamentals of robot technology. We are going to discuss about basic elements in robot system. So these are the points: robot anatomy, drive system, control system, sensors, and end effectors used in construction of robot system. So degree of freedom, this is again the basic parameter used in design of robot manipulator. Degree of freedom, we all know the definition of degree of freedom. Okay. So it means the number of directions through which that robotic arm can manipulate. Okay. So 3 translation and 3 rotational movements. Okay. Total 6 degree of freedom for every component we can assign in a space. So the basic elements involved in robot arm are base, then link 0, link 1, and link 2. This is one example of robotic arm. Okay, and these links are connected with the joints, joint 1 and joint 2. And the end portion of the robotic arm, that is end of arm, at which robot gripper is connected. Okay, so the movement of robot gripper is controlled by these links and joints, and a few control system, drive system, as well as sensors are attached to this robot manipulator. These are some types of joints used in robot arm or robot manipulator. Linear joint, that means linear motion provided through this joint, input and output links move relative to each other. Orthogonal joint, perpendicular movement of two links. Rotational joint, rotational movement, relative rotational movement of two links. Twisting joint, one link is fixed, another link is rotated about that joint. Then revolving joint. So these are type of joints used for various robotic manipulator design. Then 3 type of basic joints. These are the 3 types of basic joints: revolute joint, prismatic joint, and spherical joint. These are differentiated with respect to their degrees of freedom assigned. For revolute joint, 1 degree of freedom along y-axis is assigned. For prismatic joint, 1 degree of freedom linear motion along x-axis. And for spherical joint, 3 degrees of freedom rotation along 3 axes are assigned. This is an example of 6 revolute joint arm. This is again this 3 degree of freedom wrist assembly is designed with reference to human arm, okay, human wrist. and shoulder and hand. So this movement, human hand movements are reflected in this 3 degree of freedom wrist assembly. These 3 degree of freedom are nothing but rotational degree of freedom, and different names are assigned to each degree of freedom. Let us say pitch is rotational movement of this link about horizontal axis. Then yaw, this is again rotational movement of this second link about this vertical axis. And roll is again third rotational moment of this disc, which is at the end of robot arm, okay, about this horizontal axis. So roll, yaw, and pitch, these 3 degree of freedom or these 3 rotational moment are assigned to this assembly. And the last point, that is 6 robot configurations. Okay, so robotic arms are designed with reference to these configurations. Polar configuration, this polar type of robot having one translation and 2 rotational degree of freedom assigned. Then cylindrical type, for cylindrical type we have 2 translational and 1 rotational degree of freedom assigned. Then Cartesian robot having 3 translational degrees of freedom assigned. Then jointed arm having 3 rotational degrees of freedom assigned. Then mobile and SCARA robot is one of the advanced robot system. So nowadays every automation industry use this configuration SCARA having 2 rotation and 1 translational degree of freedom assigned. So further kinematics of robot and how what is the procedure of robot gripper design is explained in this PPT. These are some sensors, drives and control system, type of DC motors and pneumatic cylinders used in robotic system. Thus types of gears, 16 teeth, 8 teeth, 40 teeth gears are used in robotic system. Okay. So this is about the basics of robot configuration, types of robot, joints and links provided for robot construction of robot system and degrees of freedom we have discussed. Okay. So we have to complete this experiment as an assignment, and we have to complete those two assignment for the submission. Okay. Thank you.